Okay, welcome to the Core Concepts class question book. And whenever you're doing this, you need a few things with you. A calculator is a must for biology, as you might have realised by now. Pencil, just in case you've got to draw a graph. Ruler, in case you've got to measure something or draw a graph. A pen and a highlighter. So this is Core Concepts, and I'm just going to run through the first question, which is on cells. Some lovely calculations. So, dead important that you read the question properly, and one of the ways you can do that, I quite like boxing round words with a coloured pen, because then I read it forwards, backwards, and I'm thinking about it, but a highlighter is just as good. So, the electron micrograph below shows a section through a eukaryote cell. What do I know about those? They've got a nucleus. There's this huge structure there, so that is the nucleus, and then I've got one with little sort of bands across, and I've got circular ones and sort of cylindrical ones, and the little bands across, I recognise that, that's a mitochondrion. So, already, before I've started, I've thought, yeah, know what I'm looking at. And they've got a line across one of them, so I'm pretty much thinking I'm going to have to measure something at some point. So, the organelles labelled P and Q are both surrounded by double membranes. Identify these organelles and describe one difference between them. So pretty much, because they've commented on membranes, I'm thinking that they really want a difference, probably realistically, about membranes. So, P. This is a good plan. No, don't kind of try and think, oh, I can see the nucleus first, that's the biggest, it'll be the first. P is the mitochondrion, and Q is the nucleus. Now I want to make sure that my examiner knows that I can spell this. I'm going to do this one really carefully. If you misspell it, you're going to lose the mark, because it's very easily confused with other terms. And then I want a difference. Now when you're talking about differences, you need to say something about one and something about the other. So difference. The mitochondria so I've only got one of them. Mitochondrions in a membrane is folded into cristae and the nucleus isn't. Nucleus in a membrane. That's all right, that in. Nucleus in a membrane isn't. Okay. So, the magnification. So magnification times 32500. Calculate the actual width of the organelle in micrometers between points A and B. 3 significant figures, and show you working. So, I am thinking already I, A, M. So actual equals image size. Now what are we calculating? Yes, over magnification. So, my image size, get my ruler out, pop it across from A to B, 14 millimetres. Divided by 32500. Now I'm giving my answer in micrometers, so I'm going to do my conversion first. So that's 14,000 micrometers over 32500. So 14,123 divided by 32500. So I've got 0.430 0.7. I've only got a load of other numbers after that, but I'm only giving it to 3 significant figures, so I'm going to give it to sort of 3 decimal places. So that'll be, round up, that's going to become a 1. So 0.4, my units in 3, 1 units, micrometers. Now without units, you're not going to get a mark, is the bottom line. You are expected to do units. Then we've got another little bit here, another calculation. So the surface area can be estimated using the formula. So we've got 2 pi r L plus r. So we've got the length, L, 9.8 micrometers. We've given a value for pi, and we've got an average diameter. So length, pi, diameter. Estimate the surface area of the organelle shown. So that clearly we're talking about the mitochondrion from the previous page, with its where we've just calculated its actual length. So surface area equals 2 times 3.14, that's the 2 pi. I need the radius, not the diameter, so that's half, times 0.6, brackets, length, 9.8, plus, radius again, 0.6. So, do the first bit first, I think. 2 times 3.14 times 0.6, that's 3.768, no, 9.8 plus 0.6 times 10.4, 8.768. Again, you know, I've got 4 decimal places on my calculator. Probably don't need that many. So 39.187. Pretty much in an exam, round it to 2 decimal places, unless you're told otherwise, like it's 3 significant figures or 3 decimal places, or put it in standard form. So if they don't tell you what to do, and that's, you know, one way they can just tell you, do it to this many. I would always do it to 2, and the exception for that is if I'm working on a table and doing a mean and the rest of the table's to 1 decimal place, I would always do it to 1 decimal place. So, surface area of a spherical organelle with the same volume, okay, that's important, and they've boldened it for us to tell us it's important, is 23.9. So same volume. If you've got a sphere, it's got a smaller surface area. Scientists have concluded that there are advantages to the cell if these are cylindrical. Evaluate the statement. That means sort of say why that might be. Okay. So a cylindrical mitochondrion, that's what we're talking about, has a greater surface area than a spherical one for its volume. So there are other ways of expressing that. So you could say it's got a bigger surface area to volume ratio, if you've learnt about that at school. And we'll certainly come back to surface area to volume ratios in the very near future. The other thing is, if you're a cylinder, there'll be a shorter diffusion distance to the middle. Shorter diffusion distance. to the centre. And then you need to sit back and think, right, so what do I know about mitochondria? I know they do aerobic respiration. What does aerobic mean? Why would a bigger surface area and a shorter diffusion distance be important? Aerobic means using oxygen. So, in a cylindrical mitochondrion there is a greater rate of oxygen uptake or diffusion into the organelle, and therefore a higher rate of ATP production, or you could say of respiration, or you could say of energy release. And that's their job, isn't it, to release energy.